Hi, everyone. You may well not have seen these before, but you're going to see these a lot in Calculus 2, Math 151, sign alternators. Let's say that you have a sequence that alternates between positive and negative, right? Then what pieces will we find? Alternating sequences have terms that alternate, that is, they consistently switch between positive and negative terms. Again, you see them a lot in Calculus 2, like, for example, in series expansions for sine of x or cosine of x. So here's an example. Write the first four terms of the sequence where a sub n equals this over here. -1 all to the n times n. This piece here, in blue, is a sign alternator. -1 all to the n. Let's see what happens. Again, we assume we begin with n equals 1. So we plug in values for n equals 1, 2, 3, and 4. Okay, here, -1 all to the first is -1 times 1, we get -1. So take a look here. Okay, so the n here stays positive. We're only plugging in positive integers. The n here stays positive. The sign alternator over here tells you what sign you get. Is it going to be positive or negative? So if -1 is raised to an odd exponent, the resulting term will be negative. I'm assuming that these other pieces are positive in value. And in Calculus 2, you typically separate it out so that is the case. Over here, we have -1 to the second power. Anytime you have an even exponent, you end up with a positive, right? So we know, so the sign alternators here tell us that we alternate between negative, we start with negative, positive, negative, positive, and so forth. So we get -1, +2, -3, +4, and so forth. So recall that the parity of an integer is either even or odd. The parity of n here as an exponent determines the sign of the overall term. So the exponent is really key, right? With the sign alternator alone, all right, when -1 is raised to an odd exponent, you get a negative. When -1 is raised to an even exponent, you get a positive, assuming these other pieces are positive. So what do we do if we want to go and change these to positive, negative, positive, negative, assuming the same absolute values, these guys over here? So what do we do to get from here to here? Well, basically, if I give you something that's negative, what do you multiply by to flip it over to positive in such a way that you have the same absolute value, which is the n here? You could multiply by -1. Multiply by -1. Right? Well, what happens when you multiply -1 all to the n by -1 to the first? When you multiply powers of -1, let's say, you add the exponents. So we can use -1 all to the n plus 1 all times n. So for example, when n is 1, right? Let's see here. I'll put this in, let's see here. Put this in green. All right. So here we have the signs for -1 all to the n. Over here, we have -1. Oh, okay, I'll erase this stuff. Over here, we have -1 all to the n plus 1. So these are the signs if we have -1 all to the n. These are the signs if we have -1 all to the n plus 1. So if n equals 1, exponent here is odd, we get a negative. But if n equals 1, then 1 plus 1 is 2. -1 all squared, that gives a +1. Okay? But here's the bottom line. when n equals 1, if this exponent is odd, we get negative. If this exponent is even, we get positive. But wait a minute. When n plus 1 is even, what else is even? N minus 1. We can subtract 2, right? In other words, if n is odd, how do we switch parity? We can add 1 to the exponent, or we can subtract 1 also. So this would also work, and we get the same sequence. We get the same sequence as this one over here, where we take these terms and we basically flip all the signs. So we get positive 1, negative 2, positive 3, negative 4. It's this other sign pattern here. In fact, there are infinitely many possibilities. So to get this pattern over here, we could use n plus 1, n minus 1. We could use n minus 3. You can keep subtracting or adding by 2, right? How do you get a bunch of numbers with the same parity? You can add by 2 or subtract by 2 any number of times. Okay, n minus 3, n minus 5, and so forth, n plus 3, n minus 5, those would work. For these guys here, negative 1 to the n, what else would work? Well, negative, whoops. What else would work? Well, instead of n, we could have n plus 2, n plus 4, n plus 6, n plus 8, or n minus 2, n minus 4, n minus 6. If you take an exponent and if you add to or subtract to any integer number of times, then you'll have the same parity. And the parity of the exponent on the negative 1 will tell you what sign pattern you get. Speaking of even versus odd, if n sweeps out over all the integers, then 2n sweeps out over all the even integers. That's good to know. So if n equals 1, this is 2. If n equals 2, this is 4, and so forth. So, okay, so here's n. In fact, I'll do it this way. N equals 0. Well, no, so let's start with n equals 1, 2, 3, 4, and so forth. Okay? This wants to deal with 2n. So 2n, we double n to get 2n. 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8. Right. Now, how do we get to, so this sweeps through even integers, all right? In this case, positive even integers. We're focusing on positive even integers here. Right? Now, how do we get from here to, let's say, positive odd integers? How do we get to 1, 3, 5, 7? Okay, well, let me ask you, how do we get from 2 to 1, 4 to 3, 6 to 5, 8 to 7, and so forth? What do we do to 2n to get these values over here? We subtract 1. 2n minus 1. All right. 2n minus 1 will sweep over odd integers, also 2n plus 1. Now, if you start with n equals 0, then to get 1 as your first term, your initial term, you need to use the 2n plus 1 form. If n is sweeping out over all the integers, then it doesn't matter. These will both sweep out over all the odd integers. All right. So next up, factorials and counting. Next time.